Now welcome to our 17th lesson, and we are going to discuss bonds across the period. But before we go there, we are going to talk about metallic bond, where we stop. Now, this is a bond that is found within a metallic structure, and as we all know by now that all what metals are. Now, in metallic structure, we are going to have the kind of having a metallic bar. We are having a metallic bar like this. And when we have a metallic bar, we have atoms within the metallic bar. Now, each and every of these atoms is surrounded by millions and millions of atoms. And these atoms have got two subatomic particles that we are interested in. One is protons, and the other is electrons. The reasons why we are interested in these two is because they have what we call opposite charges. And we have valence electrons, which valence electrons are electrons being found on the outermost occupied energy level of an atom. So you find that there's going to be a mutual attraction between the protons in the nucleus and the electrons in the energy levels. And this case is going to make what we call the positive of the protons as subatomic particles to appear as if it is in a sea of electrons, because it will be surrounded by so many electrons. And this is going to be shown below. So we have this positive metal ion here, and these are the electrons, the black dots are the electrons. So we find that this positive metallic ion, or rather the protons are feeling as if they've been immersed in a sea of electrons. Now, then another thing, or another reason why we are interested, is an electrostatic force of attraction that is going to develop between these two, the protons and the electrons, and this is what we constitute to what we call the metallic bond. That is what is going to constitute to what we call metallic bonds. And metals tend to have very high boiling and melting point because of this strong metallic bond. And this pattern keeps on repeating itself. So the pattern of the atoms, the metallic, the protons and electrons attracting, constituting to a metallic bond. This is pattern going to be repeated many times, and this is what is going to constitute to what we call a giant metallic structure. So as I was saying, the electrostatic force of attraction between positively charged nuclear and negatively charged and the localized electron hold the atoms together and in what we call metallic bond. The metallic bonds are strong bonds. The pattern is repeated many times, resulting in what we call a giant metallic structure. And this is just a summary of some of the metals here. Lithium, sodium, potassium, these are all one element. Look at the melting point 98, 180, 98, 64. Look at the boiling point 1330, 890, 774. These are very high boiling points. Then we have magnesium having 651, and aluminum having 1083. So, if you look now, atomic radius of lithium is 0.133, 155, 0.2, 0.3, 0.136. Then we have 0.125. Now you can look at the one with the small atomic radius, like magnesium and and aluminum. So the smaller the atomic radius, the higher the melting and boiling point. But if now you compare lithium, which is 133, and magnesium, which is 0.33, there are two things that are going to determine the melting and boiling point. One, the size of the atom, the size of atomic radius, and the second thing that's going to determine boiling and melting point is what we call the number of the localized electrons. So even though magnesium has a bigger atomic radius compared to lithium, the advantage that magnesium has over lithium that makes it to have a higher melting and boiling point compared to lithium is because magnesium has got 2 delocalized electrons used in the bonding, while lithium has got only 1. So I would say that there are two things that are going to determine the boiling and melting point. The first thing is the atomic radius. And apart from atomic radius, there is another factor that is going to determine the melting and boiling point, and that is the number of the localized electrons, or rather electrons in the outermost energy level. So now, discussion. All metals are good conductor of electricity. As you can see, electrical conductivity of all these metals are good. So they are good conductor of electricity. And the reason as to why they are good conductor of electricity is because they have what we call the localized electrons. Now, so thermal conductivity and electrical conductivity also increases with the number of the localized electrons within the structure. For example, if you look at lithium, sodium, and potassium, they all have 1 electron, down almost energy level. Magnesium has got 2, while aluminum has got 3. Now, looking at these 3, the best conductor of electricity among these 3 categories, this is group 1, group 2, and group 3. Group 3 is the best conductor of electricity since it has more electrons which are delocalized and can move through the structure. Followed by group 2, which has got 2, followed by group 1, which has got just 1 electron in the outermost energy level. Now, so this explains why aluminum is a better conductor than magnesium. At the same time, magnesium is a better conductor than potassium, lithium, and sodium. Now, metal of relatively high melting and boiling point, as we already seen. This is because of the metallic bond, and the metallic bond is very strong and needs a lot of heat to break. Now, the melting point of lithium is higher than that of potassium. This is because lithium has a smaller atomic radius. Remember, as I was introducing, I told you that there are two things that determine the melting and boiling point, which I said the first one was atomic radius. So the first factor is being seen here, whereby lithium has a small atomic radius compared to potassium and sodium. Therefore, lithium will have a higher boiling point and melting point compared to the two. Then, and this is going to contribute to a stronger metallic bond. Aluminium has a higher boiling point than magnesium. Now, I told you the second factor was the number of the localized electrons, or electrons with the outermost energy level. Looking at aluminium has got 3 electrons with the outermost energy level, while looking at magnesium has got 2. So that means aluminium having 3 electrons with the outermost energy level has got what we call a stronger nuclear attraction. Stronger nuclear attraction between the 3 electrons in the outermost energy level and the positive center compared to magnesium. Therefore, aluminium will be having a higher boiling and melting point. This means it has a stronger metallic bond. Another reason as to why aluminium will be having a higher melting point and boiling point as compared to magnesium is because of its size. It is small, it has a smaller atomic radius, and therefore the packing of atoms in the structure of aluminum metal is greater compared to that one of magnesium. And aluminum also has more localized electrons than magnesium, which also contribute to the strength of metallic bonds. Now, that being said, we are going to put a pause there to a metallic bond. So we are going to take a break, and when we come back, we are going to start discussing now the types of bond across a period. Types of bond across a period, and the period we are going to be interested in here is period 3. Thank you.